Isometric view. In this video, we will learn how to construct an isometric view using orthographic projections. This is our fourth video on the topic. These are the orthographic projection of the object. To construct the isometric view or 3D view of the object, we first need to create the isometric axis. To do this, take a ruler and draw a horizontal line. Then, mark a center point on this line. Next, take a protractor and mark 30 degrees on both sides of the center point, as well as 90 degrees. Draw lines passing through these points from the center point. The line passing through the 30-degree mark will be the x-axis, the line passing through the 90-degree mark will be the y-axis, and the remaining line will be the z-axis. With these three isometric axes in place, we can now construct the isometric view of the object. Next, we need to decide whether to draw the front view in the xy plane or the yz plane. It's important to remember that the front view should only be drawn in these two planes, and never in the xz plane. The top view of the object is always drawn in the xz plane, so that's another key point to keep in mind. Since we will be using the first angle method to solve all the problems, the top figure will be the front view of the object, while the bottom figure will be the top view of the object. Remembering these important points will help us accurately construct the isometric view of the object. We will draw the front view of the object in the xy plane, as this will make more edges visible. To begin with, let's create the top view of the object, which is always positioned on the xz plane. We can achieve this by first sketching the outline of the object. From the orthographic projections provided, we can determine that the object's total length and width are both 70 millimeters. Thus, we'll start by drawing the outline of the top view on the xz plane. To ensure that the front view of the object is on the xy plane, we'll position this corner point of the top view at this center point. Using a drafter, draw a 70 millimeters line parallel to the z-axis. After this, we can see the width of this side as 20 millimeters. Take a drafter and draw a 20 millimeters line parallel to x-axis. Following that, we can observe that the depth of the slot is also 20 millimeters. Therefore, we can draw a 20 millimeters line parallel to the z-axis. Additionally, the width of the slot is 30 millimeters. Thus, draw a 30 millimeters line parallel to the x-axis from the endpoint of the previous line. Next, draw another 20 millimeters line parallel to the z-axis, followed by a 20 millimeters line parallel to the x-axis. Then, we notice that the total length of the object is 70 millimeters. Therefore, draw a 70 millimeters line from the endpoint of the previous line parallel to the z-axis. Finally, connect the endpoints of both the lines to form the complete outline of the top view. This represents the outline of the top view. Moving on to the next step, we notice that the thickness of the base in the front view is 20 millimeters. To incorporate this into our drawing, draw vertical lines of 20 millimeters from each corner point. Subsequently, connect the endpoints of the vertical lines to form the base of the object. Once we have established the base of the object, we can remove the additional lines that are not visible in the isometric view. This results in the final isometric view of the object's base. Now, we will draw the square shape on top of the base. In the top view, we observe that the width of this shape is 35 millimeters, and in the front view, its length is 50 millimeters. Starting from this point on the isometric view, draw a 35 millimeters line parallel to the z-axis. Then, draw another line of 50 millimeters parallel to the x-axis, connecting the endpoints to form a rectangle. Next, we note that the height of this rectangle is 50 millimeters in the front view. To represent this, use a drafter to draw vertical lines of 50 millimeters from each corner point of the rectangle. Finally, Connect the endpoints of these vertical lines to complete the square shape on top of the base in the top view. Moving on, we need to draw the inclined portion of the object. In the top view, we can see that the base of this portion is square. From the given isometric view, we can see that the width of this square is 20 mm. Therefore, mark a distance of 20 mm from this corner point along this line using a drafter and construct the square. This square will represent the base of the inclined portion. Next, mark a distance of 20 mm along the z-axis from this corner point using a drafter. Join these 2 points of the square with the top points to complete the inclined portion of the object in the isometric view. This is how the shape should look in the isometric view. Lastly, we need to draw the circular hole on the isometric view. But before that, we need to remove all the non-visible lines from the isometric view to make it easier to understand. Now, let's draw the circular hole. The diameter of the hole is 35 mm, and it's located at the exact center of the top portion of the object. To properly depict the hole in the isometric view, we need to follow a specific method. First, we need to draw a square with sides equal to the diameter of the circle, which in this case is 35 mm. Since the circle is located at the center, we also need to draw the square at the center. The width of this outer square is 50 mm, so there will be a 7.5 mm distance between the outer and inner squares that we need to draw. To draw the square, mark points 7.5 mm away from each corner of the outer square. Then, draw vertical lines from these points and parallel lines to the x-axis. This will give us the required square with 35 mm sides. Next, draw the diagonals on the square by joining opposite points of the corners. To find the length of the radius needed to draw the circle, we need to divide the side of the square in half. Since the sides of the square are 35 mm, half of that is 17.5 mm. Mark points 17.5 mm away from each corner point of the sides. Then join the endpoints of the smaller diagonal to the center points on the sides of the square. These center points will give us the length of the radius required to draw the circle. Take a compass, using this point as a center, adjust it to this length and draw an arc as shown. Similarly, using this point as a center, draw an arc as shown. Next, using this point as a center, adjust the compass to this length and draw an arc. In the end, using this point as a center, draw an arc. This is how the final circle looks in the isometric view. This is how the final figure looks in the isometric view. After this, do the dimensioning of the figure. This is the final isometric view of the object. I hope this tutorial helped to understand how to construct the isometric view of an object from its orthographic projections. If you found this video useful, please give it a thumbs up by clicking on the like button. And if you're new to my channel ADTW Learn, make sure to